So we were talking about the source region map, and it just shows you different climates and different temperatures. Um, this one here is continent tropical. There's continent equator near the center of the earth, and also maritime equator. There's maritime tropical in the ocean areas. So tropical means warm or hot. It's mostly hot in the equator zone right here where the zero goes across. That's where you're going to see the highest heat, and then the tropical will be just north and south of the equator, and then the polar zones will be the furthest north and south because they're close to the north and south pole. And so depending on where we're at in the globe also affects those source regions. So what are source regions? Well, source regions are it describes the climate, and it kind of describes what's going on. So the first letter tells you if it's over land or sea. So C is continental, which means it's land, and M is maritime, which means it's ocean. Continent and continental are similar words, and maritime is like marine, so that can help you think of the ocean. And it affects how much of the humidity is in the air. So since we're inside the continent more, that's why it's really dry in Utah, is because we don't have any very tropical moisture type things. We have warm areas. There's not a lot of water around us, so we don't have water in our air because we don't have a lot of water. The second letter tells you about the region that it came from. So P is polar, T is tropical, E is equator, and A is Arctic. Arctic is the north and south pole, equator is the center of the earth, tropical's between the equator and polar, and then polar is between Arctic and tropical. So it kind of goes equator's the hottest, then tropical's right above and below that, then polar is above and below those, and then Arctic is on the north and south pole. Some air masses that affect the continental U.S. weather is their CP, which is dry air from Canada, so it creates high pressure. That's kind of in this northern area. In CA, kind of in like the North Dakota area, you'll see it's from the Arctic Ocean, and it's really cold there. MP right here is kind of the Oregon area, and it's cool, moist air. And then MP over here in like the eastern coast is cool, moist from the Atlantic Ocean. And there's usually not a lot of effect because of the wind. It kind of blows it away from the east coast. And then MT is here near Florida, Louisiana, and also near California, Arizona. They have hot, wet air. And then MT, they're both. This is cooler and drier, which is kind of what describe Utah, the area we live in. And over here, it's hot and wet. So it's really moist down in the southern area. And then hot air that's dry and very persistent. That's like Texas. If you've ever been to Texas, especially in the summer, it feels like a heater's blowing on you. That's hot air. So in relation to where the air is, and if it's above water, how close it is to water, and it will affect the kind of climate that we have, the moisture that's in the air. Air masses are slowly pushed by the wind. So when air masses move into a new region, it brings its temperature and humidity with that to that region. So weather, temperature, and humidity of a particular location is influenced by the air mass that sits over it. Where two air masses meet is known as a front. So a weather front is separating two masses of different densities. So there are different types of weather fronts. These two air masses have different densities. So you can see the different amount of air masses and the density they have. And sometimes you can see those really clear with the clouds, and you can see the front, and you can see, oh, a storm's coming. So weather changes at the front. So for example, tall storm clouds such as thunderheads usually form at cold fronts. As the front moves through, cold, fair weather is likely to follow. Warm fronts bring rain showers and low flat clouds. As the front passes, temperatures rise and the air becomes more moist. So these symbols are used on a weather map to show which type of weather front is happening. So if it's got this little round area like this one up here, it's a warm front. If it's got the little like triangles, that's a cold front that's moving in. That's where that air's meeting, like that whole high and low temperature air pressure is meeting and creating that front. So you can see there's some low pressure bands here, and that's what's creating that front. If it's purple, which I'm not seeing purple on this, oh, there is a little bit of purple right here. It's an occluded front, and if it's blue and red together, that means that it's a stationary front, so it stays pretty in the same place all the time. The leading edge of a moving mass of cooler air is called a cold front. So a cold front moves into an area and the heavier cool air pushes under the lighter warm air that it's replacing. So the warm air kind of moves out, and we've experienced that a lot in Utah, where the warm air moves out and the cold air will move in, and that's a cold front. And that air pressure is kind of helping to push that storm along. Cold fronts move quickly and cause abrupt weather changes, including violent thunderstorms. Rapidly moving cold air runs into a slowly moving warm air mass. The denser cold air slides under the lighter warm air, pushing it forward or upward. The rising air cools and condenses, forming clouds, heavy rain, and snow may fall. If warm air masses contains only a little water vapor, there may be only cloudy skies. So you have to have enough water vapor to cause precipitation. After a cold front passes through, cool, dry air moves in. Clear skies and cooler temperatures often follow these cold fronts. So this is kind of showing what's happening, is that warm air is going up, out of the way, and the cold air is pushing through. The leading edge of a moving mass of warmer air is called a warm front. A warm weather front is defined as a changeover region where warm air mass is replacing the cold air mass. Warm fronts usually move from the southwest to the northeast, and the air behind the warm front is warmer and moister than the air ahead of it. A warm front is moving warm air mass collides with slowly moving cold air mass. The warm air moves over the dense colder air. If the warm air is humid, showers and light rain fall along the front where the warm front and cold air meet. If the warm air is dry, scattered clouds form because the warm fronts move slowly than the cold fronts. The weather may be rainy or foggy for several days. Occulated fronts. Occulated fronts are associated with areas of low pressure called depressions. When a depression forms, there's usually a warm front and a faster moving cold front. The warm air mass is replacing this cold air at its leading edge of the warm front. As the depression intensified, the cold front catches up with the warm front. Remember, it moves faster than the warm front, so the cold front moves a little faster. The line where the two fronts meet is called an occluded front. When an occluded front passes overhead, you would feel changes in temperature and wind speed. Occluded fronts can generate quite stormy weather as they pass over. So this is the advanced cooling air, and this is the warm air. But if it's an occluding front, you have the cold air and the warm air, and they kind of mix together. And so the cool air in its place causes that occluded front. So this shows the amount of low pressure, and it kind of shows the wind direction that's blowing and what happens. So, you know, we have this cold front here, and this warm front is pushing the warm air away, and the cold air is coming in. But in this occluded front, it's kind of blowing it all together. So you won't see the change in weather as much. A stationary front is a pair of air masses, neither of which is strong enough to replace the other. On a weather map, this is shown by interplaying series of blue spikes pointing one direction and red domes pointing in the other. So they don't really replace each other, they just kind of mix together. And so you'll have cold air on one side of the front and warm air on the other side of the front. And if you identify cold fronts, you'll see that this air here is going to be cold and this one's warm. So this is kind of pushing that along. This low pressure band is kind of separating the cold air from the warm air, and it's kind of pushing that along. And a lot of times you'll see that come with storms. And then this is showing some high pressure, so it's really calm, nice in the middle of the country, but there's low pressure front coming in here, and then also a cold front coming here that's going to push that warm air out. We see that again here where there's high air up here, so there's a lot of high pressure, and this low pressure front is pushing it. So even though on the radar you see a lot of moisture, it's not mixed with the low front, so it's probably not going to be snow, it's just going to be rain, and it's going to push that weather along with the high pressure. And then this shows a band of low pressure and another band here. So you'll see this low pressure front with a lot of weather here in the middle. You'll see nice fair weather above it and nice fair weather below it, except for right here where this little low front is. You'll see all this nice pressure here, but then here you won't see it as much. So why does high pressure move towards low pressure? It moves to low pressure because high pressure particles are pushing harder than the low pressure. So you got to imagine it like it's really a thing. Air's really a thing. That's why a balloon blows up. So that high pressure is going to push way more than that low pressure. And so the high pressure is going to push more, and it wants to replace that. And so wind will move from areas where it's colder to areas where it's warmer. That's a lot of the reason we get changes in weather that we get. Warm air rises because the molecules are less dense, so it creates a low pressure zone. Air from the surrounding area is sucked into the space left by the rising air, and the risen cold air becomes more dense until it descends. Where it reaches the ground, it creates a high pressure zone, and air flowing from areas of high pressure to low pressure create wind. So the low pressure ends up getting pushed out by the high pressure, so it goes up higher, but then it will push to the low pressure, or the high pressure will push, and it just creates this wind. The circular pattern of air movement is called a convection cell. Isobars connect areas with equal air pressure. The distance between the isobars is called a pressure gradient. The closer the isobar lines, the greater change in air pressure and the greater faster wind speeds. So you're going to see a lot more wind where it's closer together than where you see it further apart. High pressure systems bring clear, sunny weather and wind flows out and clockwise. Low pressure systems bring overcast, stormy weather and wind flows in and counterclockwise. So here's a few other weather terms that you need to know. Dew point is the temperature at which water vapor can condense and form dew. Water vapor changing back into water must happen in order for clouds to form. We talked about that, the water cycle. That's condensation. And relative humidity is the amount of water vapor in the air. So dew point is water vapor condensing, and that's usually before it's up into a cloud. It's happening on a plant or something. It attaches to something and turns back to water. Condensation is what's happening in the clouds, and then humidity is how much moisture is in the air. So whether it's water vapor or actual water, it's how much is in the air. So we're going to look at this weather map that's next. I'm actually running out of time on this video too. So we will do a little shorter video the next time and finish up the last couple things that we need to finish up for today. Okay, so go ahead and watch the third video now.